Hello everyone. In today's video, we are diving into the dynamic side of the routing protocols. So in the previous lab, we have look at the static routing. We saw how the router find the best path to a network. We configured static routes and traffic was able to flow between the routers. So in this lab, we are giving an overview of dynamic routing protocols. We will define them and learn how they are different from the static routes. We will discuss their advantages over the static routes, learn the different categories of dynamic routing as well as classless and classful nature. We will also talk about the administrative distance and the metric value, and also find out how dynamic routing is calculating the best path to reach the destination. So what are dynamic routing protocols? So dynamic routing protocols are the algorithm used by a router to discover and share the information about the neighbor. So unlike the static routing where routes are manually configured, dynamic routing allows router to exchange the information dynamically, adapting to change in the network topology. So let's say if we make any kind of change in the network topology, dynamic routing will automatically adapt that change and provide the best path to reach the destination. So it is a set of algorithm which is used by a router in order to forward the packet by choosing the best path by establishing the neighborship and adjacency. Broad level, there are two types of dynamic routing. One is IGP and another one is EGP. So IGP are interior gateway protocols, EGP are exterior gateway protocols. So IGP protocols are used to exchange the routes within an organization. So let's say it's a single autonomous system and we want to exchange the routes between those autonomous systems, then we use the interior gateway protocol. So AS path or autonomous system, if we talk about, autonomous system is a group of device having the same routing policies and controlled by a single administrator. So this is the this is known as autonomous system. And if we talk about the EGP protocols or EGP, so if we talk about the EGP, these protocols are used to exchange the routes on the internet. So basically IGP protocols are also configured between two different AS. However, there are some limitation due to which it is not preferred. IGP can only handle up 60 to 70,000 routes at a time, depend upon the hardware. So if your hardware is capable, this IGP protocol is also capable to handle this much of route. But for a large scale or for the routes which is coming from the internet, there are millions of routes over the internet. So those routes cannot be handled by any IGP protocol at a time. So that's why there is an EGP protocol which is there to handle this kind of routing topologies. So if we talk about IGP protocols, they are further categorized into three different categories. One is distance vector routing protocol, which is known as DVRP. So DVRP having two different routing protocols. One is IGRP, which is interior gateway routing protocol, which is not in use as of now. And apart from that, there is RIP version 1 and version 2, that is routing information protocol. And then second category is link state routing protocol. In this we have two routing protocols, OSPF and ISIS. In today's network topology, OSPF is using broadly and ISIS is used by the ISPs to exchange their routing information. And there is one more IGP protocol, that is advanced distance, that is there is one more IGP protocol, that is advanced distance vector routing protocol, or we can call it as a hybrid routing protocol, that is EIGRP, which is an enhanced version of IGRP protocol. And we have only one EGP protocol, that is known as BGP, that is a path vector routing protocol. So we only have a BGP as a EGP protocol, which is used for the communication between different AS. We use BGP in our network. So now question is, why we use dynamic routing if we have a static one? So if we use the dynamic routing, there are few advantages. First advantage is adaptability. So if we are using a dynamic routing protocol, automatically it change according to the network topology. If we make any kind of change in the network, any routing information got changed, it will automatically replicate or it will automatically share with their neighbors. And it is efficient. They can calculate the best path for traveling the packets or data basis on the algorithm used. It will help enhance the performance of the link. In a larger network, dynamic routing protocol reduce the administrative overhead of manually configuring the route on each router. So this is scalable also. So today we will talk about the dynamic routing protocol. So if you look into this diagram, it having an architecture. So in this, the administrator overhead that would be needed to make a communication between all these devices would be considerable. So all the static route would have to be configured. So if we in this network, if we configure the static route, this will be a great task, because we have to manually configure the routing on each and every device. So the easier solution for this is a dynamic routing protocol. So dynamic routing protocol are the solution that is used in the larger networks so as to reduce the complexity in the configurations. So we can do dynamic routing in this scenario instead of static routing. So we will discuss about DVRP, distance vector routing protocol. So distance means how the destination is located. So we only advertise the indirectly connected network in the static routing. So no tracking of route or path is available in static routing. We can achieve tracking via IPSLA, but there is no automatic tracking of path. But in dynamic routing, we only advertise the directly connected routes. We never define the next hop. We only configure the directly connected network, and router will exchange the update message, and it will set the network information in the update message. So so in dynamic routing, the best path selection will basis on the least matrix. It will automatically share the neighbor information to its connected devices. So if we talk about the AD value of routes, so directly connected route is AD having 0, static is 1. If we talk about the IGP protocol, so RIP is having AD value of 120, EIGRP is 90. So EIGRP having 3 AD values, one is 90, one is 170, and then for summary it is 5. 90 is for internal, 170 is for external routes, and 5 is for the summary route. So EIGRP having 3 different AD values. OSPF has AD value of 110, ISIS is 115, BGP also having 2 AD values, so eBGP having AD value of 20 and iBGP is 200. So one more point, so AD values, whatever the AD values any routing protocol have, these are locally significant, means these will never forwarded along with the update or route information. So there is a question, how any router know that route received needed to install on which AD value? So this is because of routing protocols, and AD value is already predefined on a router. So that's why it will automatically install that particular route against that AD value. If you configure OSPF, it will automatically take AD value of 110. If you configure eBGP, it will automatically take the AD value to 20. So these AD values are predefined in OS, so it will automatically install that route against that particular AD value. However, it will never exchange in the update because AD value is locally significant, so it will never exchange in the update part. So if the AD value is matched, it will check the least route precedence, which is the lowest matrix value. So it will calculate the best path basis on that. So DVRP, if you talk about the DVRP, it will use the hop count as a matrix. Hop count means the distance is located, how many, what is the distance or what is the number of hops available on the network. It will calculate the best path basis on that. So if we talk about the other routing protocols like distance vector protocol. So today we will further discuss about RIP also. What is RIP? So RIP is the oldest routing protocol, which is simplest dynamic routing protocol used in the computer network. It is categorized as a distance vector protocol and often used in small to medium size of network. So RIP operate by routers exchanging the information about the routes they know with their neighbor routers. Each router then updates its routing table based on the information. So RIP use a matrix called hop count, representing the number of router as a packet must travel to reach the destination. So we will further check the configurations of RIP also. So AD value of RIP is 120 and it work on network layer of OSI model. So it use a port number, TCP port number 520. So we have talked about hop count. So hop count is the number of router occurring in between the source and destination. The path which is with the lowest hop count is considered as the best route to reach a network, and therefore it placed in the routing table. So RIP prevent the routing loop by limiting the number of hops. So to prevent the loop in RIP, it limit the hop count between source and destination. So maximum hop count in RIP is 16, and hop count of 16 is considered as a network unreachable. So whenever the 16th hop came, it will automatically consider it as an unreachable device. So it is known as root poisoning. So it will poison the root whenever a neighbor prefix goes down. So router will always send a metric value of 16 for that prefix. So if the 16th hop is coming, it means the network is unreachable and it will consider that particular path as down. So if we talk about the features of RIP, updates of the network are exchanged periodically and update are always broadcast. So routing information which will send from one router to another router, it will always broadcast. So every time full routing table are sent in the updates, and router always trusts the routing information received from the neighbor router. So this is also known as routing on a rumor. So means it will always believe that the routing information which is coming from the other router is always correct. If we talk about the versions of routing protocol, so we have three versions in RIP: RIP version 1, version 2 and RIP NG. So RIP version 1 and version 2 are for IPv4 and RIP NG is for IPv6. So RIP version 1 version 2 having some difference. RIP version 1 always send updates as a broadcast, but RIP version 2 send the updates as multicast. RIP version having a broadcast ID of same 255.255.255.255, but RIP version 2 having a multicast address to 224.0.0.9. RIP version 2 also support authentication. However, RIP version 1 doesn't support authentication. RIP version 1 is a classful routing protocol. However, RIP version 2 is classless routing protocol. So in RIP version 1, update which is forwarded is without the subnet mask. However, in RIP version 2, which is a classless protocol, it will always send the update with the subnet mask also. So RIP version 2 and RIP NG also send the update along with the subnet mask. It's also a classless protocol, but that is used for IPv6 only. So if now moving into next, we will talk about the RIP timer. So there are 4 timers in RIP. One is update timer, which is 30 seconds. Every 30 seconds it will periodically send the routing table update to the neighbor router. Then if no update come until next 180 seconds, so it will declare that particular route as a down, or it will consider that that next hop is not reachable. So whole timer, the time for which the router wait for neighbor router to respond, it will wait for 180 seconds by default, else it will flush that particular route. So flush time is by default 60 seconds and it will declare it that route as invalid after 50 seconds. So total time will be the whole time plus the flush time. So total time when the route got flushed from the routing table is 240 seconds. So these timers can be modified. You can modify according to your requirement. These timers are adjustable. So we will see in the lab also how we can adjust the timers on RIP. So let's move into the lab. We will create a simple architecture. We will take 3 routers. So we have 3 routers connected. We will create a network. So those are connected through fast Ethernet interface, fast Ethernet 0x0 to 0x0 and fast Ethernet 1x0 to 1x0. So we will configure the loopback on these devices. This is the architecture. We have created connected 3 routers having the IP configurations on the interface. We have created 3 loopback address, different loopback address on all the 3 routers. So let's move into the configuration. We will start all the routers and then we will open the console of all the devices. So we click here, it will open the console of all devices. So now we are into the console of all the routers. Let's do the IP configuration quickly. So IP address will be 172.16.10.1. Subnet mask will be 255.255.255.252 and no shut. Then interface loopback 1, IP address 10.10.10.1, 255.255.255.2.0. Do show IP interface brief. So this will show you the IP configuration on the router R1, and we will configure interface F 1x0 also. Interface F 1x0, then IP address 172.16.10.5.255.255.255.252 and no shut. So we have configured all the three IP address on router R1. So if you do show IP interface brief, it will show you the IP configuration here, or else if you run the do show running configuration, it will show you along with the subnet mask. So do show run. So you can able to see what are the IP configurations and subnet mask on the interface. So this will show you the entire configurations you have done on the interface. Similarly, we will do the configurations on the router R2. So we will move into configure terminal, then interface, fast Ethernet 0x0, IP address 172.16.10.2.255.255.255.252 and no shut. Then we will move into interface, loopback 1, IP address 192.168.10.1 255.255.255.0. do show IP interface brief. So in router 2 also we have configured. Similarly, we will do on the router 3. So we will move into configure terminal, IP address. Now first move into the interface, FA 1x0, IP address 172.16.10.6.255.255.255.252 no shut. Interface loopback 1, IP address 192.168.20.1 255.255.255.0 do show IP interface brief. So now we have configured the IP addressing on all the routers. Further, we will going to configure the RIP, or we are going to enable the RIP routing protocol now. So if you run the command show IP protocol, you can able to see IP routing is NFS aware. Right now no routing protocol is enabled on the router. So we are going to enable RIP on router R1. So we will get into the configure terminal. We will type router, and if you put the question mark, it will give you all the routing protocol which we can enable, that is BGP, EIGRP, ISIS, IGRP for OSI network. Similarly, we have OSPF version 3 and RIP. So we are going to enable RIP here, and we will define the version. So we are using version 2, and we have to disable the no auto summary. So we will disable no auto summary. So we have done no auto summary, and now we will define the network. So it will network. So in dynamic routing protocol, we only have to advertise a directly connected network. So we will define the network here. On router R1, there are 2 networks connected. And also we have to define 172.16.10.4. So we have defined all the 3 network here. So as soon as we have configured the network information, you can able to see if we run the do show IP protocol, it will show us the routing protocol is RIP, and it will show the net interfaces on which it got enabled. So this is on fast Ethernet 0x0, fast Ethernet 1x0 and loopback, and the routing informations are there which networks are getting advertised. And if you check the distance here, default is 120. So this is the AD value of RIP. It will automatically take that AD value from here. So moving into next router R2, we will configure second router. So similarly, we will enable router RIP. Then we will define the version 2 and no auto summary. Then we will define network. So there are 2 network connected, 192.168.10.0 and another one is network 172.16.10.0. So if we run do show IP protocol, So you can able to see it got enabled on fast Ethernet 0x0 and loopback interface, and these are the routing network which is getting advertised. Now we are going to configure it on router R3. So in our router R3 we will get into the configure mode first, then router RIP version 2, no auto summary, and we will define the network. In network we have to define 192.168.20.0 and network 172.16.10.4. So do show IP protocol. So now if you see we have enabled the routing information here also. So now you can able to see routing information source got updated. It is getting a route from 10.5 with AD value of this. So if we check the routing information now, if we check the routing table, show IP route. So now we can see we have a two routes which is received from RIP for reaching 10.network and 20.network via different next hop address. So this will dynamically learn from that particular network. So we didn't have to manually define any routing now. It will automatically learn from the routing protocol. So if we check the routing information for this particular route, so now you can able to see this is known via RIP, distance is 120 and metric value is 1. Redistributing via RIP, last update from 172.16 on fast Ethernet 19 second ago, and this is the complete routing information. What is the route matrix here and what is the traffic share count. So this will show you the entire routing information this for particular network. So if we check the reachability from router R1 to R3, we will simply type ping 192.168.20.1 and we will define the source 10.10.10.1. So now you can able to reach this particular network from router R1. So we will check the reachability for 192.168.20.1 network from router R2. So we will check 192.168.20.1 source 192.168.10.1. So it is reachable. If we check the trace route, so first hop is 172.16.10.1, which is the router R1 interface IP address, and second hop is 172.16.10.6, which is the interface IP configuration on router R3. So this way we can configure the dynamic routing protocol. We have checked RIP today. In next labs we will work on EIGRP and OSPF also, how we can configure EIGRP and OSPF and what is the behavior after configuring those routing protocols. We will get into the depth also. So this is a quick guide to configure the RIP on the Cisco router. So we have discussed about the dynamic routing protocol and how we can configure the RIP protocol on router. So if you found this tutorial helpful, give it a thumbs up and share it with your networking peers. Subscribe for the more networking insights. Stay tuned for our upcoming videos. We will explore more routing protocols and networking concept. Until then, happy routing and enjoy.